Alright, now, what I want you to notice is that we've got a proportion here, and the way you solve proportions is you cross multiply. So we're going to take RT and multiply it by UR plus US, and then we're going to take RU and we're going to multiply it to TR plus TQ. And right over here is where I've started doing that. RU times TR plus TQ, and that's going to be equal, so we'll write an equal sign right there, to RT times UR plus US. Now I'm going to work the algebra kind of down here because it's a little long, but basically what's going to happen is we're going to use the distributive property, multiply that out, use the distributive property and multiply that out, and hopefully end up with the conclusion that we're looking for right here. Alright, so let's see here. If I take RU times TR times TR, remember these are numbers. We don't have line segments over them, so we're not talking about the line segment itself. We're talking about the value of how long it is. Then RU times TQ, and set that equal to RT times UR plus RT times US. And then let's see here, we've got RU and RT on both sides, so we can cancel those. RU times TR, RU times TR, subtract, that's basically subtraction property of equality. You can see here that we have left RU times TQ plus RT times US. Exactly what we needed right up here. Because if you cross multiply, what we're trying to prove here, RU and TQ are going to be together. RU and TQ. And then RT and US are going to be together. Right here. So basically, we can undo that and we can end up with this statement. So step 7 is going to be the final statement. RT over TQ is equal to RU over US, and we'll just call that simplify. Alright, the property of proportions, honestly, is what that is. Property of proportions. Prop of prop. Alright, we'll put a little therefore there. So anyway, that's the proportionality, the triangle proportionality theorem. It's a really good one, and we'll use it in our homework quite a bit. Alright, the next one, again, is one that you're going to need to pause the video and go ahead and write this stuff down so that way you have it, and then I want you to start the video again when you're ready for us to prove it. Stop the video now. Alright, hopefully you've got that done. The parallel line proportionality theorem says if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So, in other words, when we've got parallel lines cut by transversals, then we know that CB over BA is going to be equal to DE over EF. So just another way to set up proportions. Alright, you can see here that we're going to draw an auxiliary line in here, a line that's really not part of the proof, not part of the theorem itself, but it is part of the proof. So hopefully you got that in there. Alright, so of course step 1 is the given information. All of the lines are parallel. Step 2 then is to draw that auxiliary line. So I want you to draw, if you haven't already, line segment AD through point X. Through point X. And the reason there is between any 2 points we can draw a line. Between any 2 points there is a line. Alright, step 3. Now, since we've got basically, you see the triangles in here? There's a triangle here and another triangle over here. Hopefully you can see those 2 triangles in there. And because we have those triangles, we know that DX over XA, so here's dx, dx over XA has to be equal to CB over BA. And we know that because we just proved that up here in the triangle proportionality theorem. We also can get from that and XD over AX is equal to DE over EF. So XD is right here over AX is equal to DE over EF. So hopefully you can see what's going to happen here. Notice we've got the same thing on both of these proportions. So since both of these are equal to the same thing, I have a feeling I know what's going to happen here. In other words, that's the triangle proportionality theorem that we just used, that we just proved. So step 4, CB over BA is equal to DE over EF, right there. And we can just call that, you can call it transitive, you can call it substitution, whichever one you would like. And that's a therefore. Alright, the next one, the triangle angle bisector proportionality theorem. Pause the video please, write all that down, and then come back and we'll talk about it. Alright, the triangle angle bisector proportionality theorem says if a ray bisects an angle of a triangle, then it divides the opposite side proportionally to the lengths of the other two sides. In other words, we're going to prove that when we have a ray here and it's bisecting that angle, we're going to prove that YW over WZ is equal to XY over XZ. Kind of interesting. Alright, hopefully you have your given information written down. You know that this angle is bisected, and so basically we have those angles are congruent. We're going to extend XY to point A so that AZ as in zebra is parallel to XW. Kind of ran out of room there. Alright, so basically we're just doing a construction, or between any 2 points is a line. Step 3, we know that XY over XA is equal to YW over WZ. And that's the triangle proportionality theorem. Triangle proportionality theorem. So let's look at that. XY over XA, that's this one right here, is equal to YW over WZ. Do you see the triangle in there? The big triangle with the line, the parallel line in there? This part is over this is equal to this over that. Step 4. Angle WXZ is congruent to angle XZA. WXZ, that's this one, would have to be equal to XZA. So this angle right here has to equal this one. Alright, and that looks like alternate interior angles are congruent. You've got the lines parallel, so alternate interior angles are congruent. Number 5, angle YXW is congruent to angle A. YXW right here is congruent to angle A. That looks like corresponding angles to me. Corresponding angles are congruent. Step 6, angle A therefore has to be congruent to angle XZA. Angle A has to be congruent to XZA. That's this one right here. Alright, and that's definitely going to be transitive. All right, so if all right, now this is going to show why this is transitive. If you notice right up here, you have YXW, which is right here, is congruent to WXZ. Here, let's WXZ, which is right here. Alright, so if these two things are congruent, then these two have to be congruent. And that's why we called that transitive. Alright, if this is congruent to this, and then these are each congruent to something else, then those two things must be congruent. So that's transitive property. Alright, so then the next thing we have here is number 7. XA is congruent to XZ. And that is the base angles congruence. Base angles are congruent converse, alright, which means that if the base angles are congruent, then the sides are congruent of that isosceles triangle right there. Got base angles congruent, so these two sides must be congruent. Step 8, XY over YZ has to be equal to YW over WZ. And the reason there is just basically substitution. Alright, so you can see up here we have this theorem. Instead, in place of the XA, we're going to put the YZ in. Alright, and here in place of the, well, this already has a WZ on it, so that's okay there. Alright, number 9. Therefore, YW over WZ is equal to XY over XZ. And basically I just flip-flop that over on the other side there so that it matched the top. So that's the symmetric property. Alright, if you have any questions about any of that, let me know. Oh, you probably need to be able to see that. Sorry about that. Now you can see it better. Alright, you had the substitution property down here at the bottom and then the symmetric property. So let me know if there's anything else you need. Oh, one more thing here. This should be an XZ, not a YZ, and my pen did not, I think I put that down as YZ. Didn't read that very carefully. That way these bottom ones match. If XA is congruent to XZ, what we did here was we took the XA out and we put the XZ in, and that's where this statement came from. I just wanted to make sure I cleared that up, that that's an XZ and not a YZ.